Okay, case 3, when x minus y is even and x plus y is odd. Now let's begin. What does it mean for x minus y to be even? X minus y is even means that x minus y can be written as 2k1. Now x plus y is odd means that x plus y can be written as 2k2 plus 1. Remember, our k1 and k2 are both integers. Okay, now our f of xy is equal to 74 means that 2k1 times 2k2 plus 1 is equal to 74. This means that k1 into 2k2 plus 1 is equal to 74 divided by 2. Now this means that k1 into 2k2 plus 1 is equal to 37. Now in this case we cannot just conclude like that, so we'll try a way to find k1 and k2. Now the left hand side means you're multiplying two numbers and the right hand side is actually 37. So the equation is saying that when you multiply two numbers you yield 37. So let's remember something. 37 is a prime number because the factors of 37 are simply 1 and 37, which therefore means that 37 can be written as 37 times 1 only, or 1 times 37. So in this case we are going to deduce something. k1 times 2k2 plus 1 will definitely be equal to 1 times 37, or k1 times 2k2 plus 1 will be equal to 37 times 1. So now in this case we can see two things. Either k1 is equal to 1 or 2k2 plus 1 is equal to 37, and in this case we can see that either k1 is equal to 37 or 2k2 plus 1 is equal to 1. Now let's solve these two equations separately and we get the values of k1 and k2. Now in the first case we have that k1 is equal to 1 and 2k2 plus 1 is equal to 37, meaning that k2 is equal to 19. Yeah, that is 37 minus 1, 38, 36 divided by 2, sorry, 18, not 19, 18. Okay, now that's for the first case. Now for the second case we have k1 to be equal to 37 and 2k2 plus 1 to be equal to 1, meaning that k2 is equal to 0. So for sure k1 and k2 are integers, and the result have actually healed the fact that they are integers. But now originally we had x minus y to be even, meaning that x minus y is 2k1. Now our k1 for the first case is 1, so it therefore means that x minus y is equal to 1. We can call this the first equation. Now secondly we had x plus y to be odd, which means that x plus y can be written as 2k2 plus 1. So it means x plus y is equal to 37 for sure, equation 2. Now if we add equation 1 and equation 2 we are going to get 2x is equal to 39, meaning x is equal to 39 divided by 2. But what do we know? X belongs in the set of integers. 39 divided by 2 does not belong to the set of integers. So we see the contradiction. Now if we take the first equation minus the second equation, we are going to get 2y is equal to negative it's 2. Let's be careful. 2. Now when we add, we have 39 for sure. 2y is equal to negative 35, meaning y is equal to negative 35 divided by 2. But what do we say? We said y was an integer, but negative 35 on 2 is not an integer, so we see the contradiction. Now if we take the second case where k1 is 37, so case 2, here was case 1 of case 2, yes, case 2 of case 2. We have k1 to be 37 and k2 to be 0. Okay, it means that we know x minus y to be even, means that x minus y is equal to 2k1, where k1 is 37, so x minus y is equal to 37 times 2, 74. Now x plus y is odd, meaning x plus y is 2k2 plus 1, but our 2k2 plus 1 is simply equal to 1, so x plus y is equal to 1. Okay, so solving the two equations simultaneously, let's say equation 1 and equation 2, 74 and x plus y is equal to 1. For sure the product will give you 74. Now equation 1 plus equation 2, we have 2x is equal to 75, meaning x is equal to 75 divided by 2, which is not an integer. Equation 1 minus equation 2 says 2y is equal to 73, meaning y is equal to 73 divided by 2, which is not an integer. So these are the various contradictions. Now the last case, case number 4, when x minus y is odd this time around and x plus y is even. Okay, what does it mean? X minus y is odd. It means that x minus y can be written as 2k1 plus 1. X plus y is even. It means that x plus y can be written as 2k2. I believe if you actually solve the same way, you're going to get the responses quite alright. So at the end, we can say that since we assume that there are integer solutions, but at the end of each case we actually seen that there exists no integer solutions. Therefore our statement, which was assumed to be true, has been contradicted. So that's definitely the proof by contradiction. So in essence, we can conclude that there are no integer solutions to the equation x squared minus y squared is equal to 74. Okay, so thank you guys for watching the video. If you love the video, please like the video, share the video and subscribe to my channel. Thank you.